The performance of structural elements are mainly considered under mechanical loadings, but structures fail due to the negative thermal effects of materials. The overall performance of structures is weak under thermal loading, so it is important to investigate before the construction. This study focuses to evaluate the thermal and mechanical performance of the steel column using a verified numerical modeling approach. The variation of material properties with temperature is considered here. In this study, the combined impact of stiffener shape and relative stiffness on the lateral performance of concrete-filled steel hollow piers under cyclic loading will be evaluated through numerical simulations. The numerical study will be carried out using finite element analysis software Abacus. The study will also investigate the effect of different levels of the relative stiffness of the stiffeners, which can be achieved by varying their geometry, material properties, or both. The results of the simulations will be used to assess the combined effect of stiffener shape and relative stiffness on the lateral performance of the piers, including lateral deflection, strain, and stress distribution. Waste materials such as plastics are used as aggregates of concrete. Use of plastic aggregate is more convenient in precast elements than in situ elements, as the precast elements are casted under controlled environment. However, due to poor bonding performance of plastics with cement, there is a strength reduction. The shear strength reduction is one of the very critical areas to be studied, as the shear failure is sudden and catastrophic. This study is mainly an experimental work where students should cost a number of precast elements and conduct testing at the laboratory to investigate the shear behavior and compare the results with the numerical modeling of the problem. Crash barriers are used to increase the safety of vehicle users. However, effectiveness of crash barriers on reducing the risk is not assessed comprehensively. Thus, this research aims to perform a comparative study to assess the effectiveness of crash barriers in selected national highways in Sri Lanka. The effectiveness is assessed based on the driver reaction criterions upon recognizing a protected bend and an unprotected bend. The drone surveying and video processing was used to assess the effectiveness of the crash bars. Many pedestrian accidents that takes place on crossings are due to negligence of pedestrians as well as motorists. Pedestrians tend to take unsafe gaps in unsignalized crosswalks, hence driver reaction is very important in preventing accidents. This research aims to estimate the risk of taking such unsafe gaps depending on pedestrian and oncoming vehicle characteristics. Controlled crossing of road was made to check the vehicle characteristics, and advanced techniques such as aerial survey via drones were used. Dapped end concrete beams are characterized reductions in the overall beam depth at the support and are ideal for precast bridge construction. The beam end represents a structurally disturbed region, and the design is complex and governed by different parameters. It is proposed to explore the sensitivity of these parameters towards the load capacity of the beams via both analytical and nonlinear numerical analyses. Critical values of the parameters are to be identified, and a preliminary experimental study will be conducted to verify the validity of the findings. Ballast is the material that supports railway tracks and provides stability to the track structure. Traditional ballast materials include crushed stone, gravel, and slag. Here, shredded rubber has been used as a replacement for traditional ballast material in rail track applications. Shredded rubber has several advantages as a ballast replacement material, such as durability, shock absorption, noise reduction, sustainability, etc. In this study, ballast mixed with the optimum content of shredded rubber will be tested for direct shear, and a numerical model will be developed to study the further influence of shredded rubber in rail track applications. The use of industrial byproducts, such as fly ash and rice husk ash, and the binders produced by the activation of these ashes have surfaced as worthy replacements for traditional binders for soft soil stabilization. However, researchers explored the one-part geopolymer synthesis, which employs solid alkali activators instead of utilizing alkali activator solutions. In Sri Lanka, no commercial value is assigned to rice husk ash and most of the fly ash at present and hence dumped to rivers and landfills. Therefore, this project focuses on investigating the potential utilization of fly ash and rice husk ash as precursors and the use of solid alkaline activators for expansive soil stabilization. The experimental work will include material characterization, one-part geopolymer mix optimization, and understanding of the reaction kinetics and determination of the strength and swell characteristics. This research will use artificial neural network machine learning toolbox in MATLAB to predict the geotechnical properties of expansive soils stabilized with fly ash and rice husk ash. The required parameters for the model including Atterberg limits, MDD, OMC, UCS, CBR, FSR, will be collected either from the literature or through own experiments. The developed neural network model will be validated by performing independent laboratory experiments for expansive soil stabilized with fly ash and rice husk ash. The use of constructed wetlands for wastewater treatment has been increased throughout the world due to their advantages such as relatively low cost and simple operation over the conventional wastewater treatment techniques. Vertical constructed wetlands are getting popular because it takes a vertical stretch of space than a conventional horizontal spread. However, clogging of wetlands due to various factors have been identified as a major operational and a maintenance problem for sustainable use of constructed wetlands. This study aims at evaluating possible mitigation measures for clogging in vertical subsurface flow constructed wetlands. Sri Lanka is full of heritage sites all over the country which are thousands of years old. Most of these sites are named as World Heritage Sites by UNESCO and they should be properly taken care after. Many of these sites have become popular tourist destinations which could help the country's economy by tourism. Conservation of these large brick structures require a special knowledge about the ancient construction methods and raw materials. It is important to recreate these old mortars, bricks, and plasters in order to preserve these ancient structures in their original shape. Hence, a special research should be carried out to find out the ancient ingredients and methodologies. Archaeological excavations prove that the interior of a stupa consists of different zones with different materials and different layouts. The objectives of this study are material characterization of brick masonry through experimental procedure and carrying out 3D finite element analysis using commercial finite element packages. Simulation of human body movements are very important in the field of sport manufacturing. The movements of the body and the muscular behavior is important in making sportwear, protective equipment as well as in manufacturing prosthetic limbs, which provides the minimum discomfort to the athlete, enhancing his performance. However, simulation of body is difficult due to various reasons. Experimental measurements using real human test subjects will be very expensive considering the measuring equipment. This study will focus on simulating soft human body parts such as breasts of a woman for static and dynamic loading, which will be very helpful in obtaining the variations of stresses, displacements, to produce a quality sports bra that enhances the performance while reducing the discomfort of athlete. These are only few of the research projects that had been carried out by final year research students. But there are plenty more important topics which cannot be unfolded within this short introductory video. Some of them are liquefaction hazard assessment of Colombo Port City, investigation of shear stresses on a bed of a chute followed by a stepped spillway, the numerical prediction of aeroelastic response of rectangular tall buildings, stress concentration on shear walls at transfer structures in tall buildings, hydrodynamic modeling of membrane-based treatment systems using artificial neural networks and CFD, rainfall runoff modeling using HEC-HMS, a study of the spreading of parking demand due to the sponge effect in multifunctional trip attractors, and many more.